Thanks, Y8H. Eyes and ears towards the board. Thank you. Let's begin. All right, you said grab out a pen or pencil. We're going to move on to 3H. Let's write some notes in. So, you have learnt so far, we did an introduction to 3G, which was percentages last session. Percent literally just means every 100. So it was always out of 100. This session is now you applying the percentages to find a percentage of an amount. So here's some example. I'm going to do one example afterwards where you actually apply it. And you can use a calculator to get you to sort of get a feel of how to do it. And then there's the fractions component, which I'll show you the technique. Okay? Well, let's start off. Here are notes. Very simple. When you're converting anything to a percentage, you just need 100 of them. That's what I taught last session. So last session I said, if you want to convert anything to a percentage, you just need 100 of them. So hence you times it by 100. Okay, so if it's a fraction, times by 100. If it's a decimal, times by 100. That will get you a percentage. Okay? Then this session is working with percentages going the other way. What if I want to convert percentages to a fraction or to a decimal? Then it's the other way, which means divide by 100. Why? Because when you say 35%, this literally means 35 out of 100. But that symbol in itself, 35 out of 100, actually just means 35 divide 100. That's why we say to convert a percentage to a fraction, well, here's my fraction. That's the fraction component. How do you change it to a decimal? Literally, what you just said here, 35 divide 100, changes it to a decimal, which we know when you divide 100, you move
2 decimal places to the left.
Very good, to the left. 2 decimal places to the left because there's 2 zeros, and technically your answer is then 0.35. So in one simple example, I've just shown you how you convert it to a fraction. Out of 100 means divide 100. If you divide by 100, you literally get the decimal component to it. Okay, so those are called conversions, going from percentage to fractions to decimals. Yeah? Today's lesson is you're utilizing the concept of proportions and you're finding proportion of a total amount. Okay, so you're trying to find, say, 35% of 200. How much is that? Okay, you're finding something like if you had 3 out of 5 correct, what is that? It's a percentage. Yeah. So here's the first 2 examples that are pretty straightforward. Dimmy scored 12 out of 20 for their test on percentages. So if I write that proportion, it's 12 out of 20. Write that in. 12 out of 20 just means 12 divide 20. That's my proportion. Now the question is, what is Dimmy's score as a percentage? So if I want to convert to percentage, how do I do that? Fraser.
Well, for this one, you can't do it for other ones, but for 20 is a factor of 5. You could multiply 20 by 5 to get it to 100, and then multiply 12 by 5, and what 12 times 5 is the percentage.
Beautiful. So what Fraser is saying there is something you might have learned last year and primary school, is to find the denominator, convert the denominator to out of 100, because the percent means out of 100. But that really depends on how strong your factors are and how your multiplications are. So that's why I normally don't teach it that way. I normally keep it very simple and just say percent means every 100. So if you want to convert this to a percentage, you literally just times by 100. Okay, but yes, Fraser's technique is actually a lot faster, but it requires that you know your multiples. So what they're saying there is the alternative method is, since we know it's 12 out of 20, but you can use equivalent fractions from chapter 3, 3a, if I want to make this 100, conveniently, we know that 20 fits into 100 how many times?
5 times.
5 times. So that's why you can say times the bottom by 5, but if you times the bottom by 5, you have to
Times the top.
times the top, because you need to keep the proportion the same. And that ends up being 12 times 5, which is what Fraser was saying, and it turns out it's 60 for every 100, which means 60%. But that only works if 20 did work into 100. What if I wrote 21? Then suddenly students are stumped, right? And so that's why I say no matter what the proportion is, if you want to change it to a percentage, it's just the idea of having 100 of them. Okay, so this technique will always work. This one requires that you know your multiples and factors well. Okay, so this is the approach I prefer that you would do. And it's all about, again, exercise 3B, I said that was your core, multiplying fractions. Before you multiply fractions, this one is a fraction on the left, but 100 is not a fraction yet. How do you write 100 as a fraction? 100 over 1, very good. It's 100 over 1 because it's how many units fit into 100? That's 100 of them. So instead of writing 100, 100 over 1 means the same thing. Yeah? Or 100 divided by 1 is still 100. Now that you got your fraction times a fraction, remember the simple technique to multiply fractions is top with top, bottom with bottom. But if you do it that way, the numbers get really large. You get 12 times 100, which is 1,200. 20 times 1 is 20. It's a really big fraction. So we encourage you to simplify early. That was exercise 3B. What two numbers can you see that you can simplify? Yes, Jay? Very good. You got the 100 and you've got this 20. What's the highest common factor of 20 and 100? Let's go with Mark. 5 is one of the factors, but not the highest common factor. It's even a higher one. Vegas? 20 is the highest one because 20 can go in 20 and 20 can go in 100. But you can still do 5. Doesn't actually matter. Yeah, the idea is just simplify as much as you can. But if you can find the highest common factor first, makes it a lot easier. So here, highest common factor is 20. Divide both of them by 20. 20 fits in 100, we know fits in 5 times. 20 fits into 20 once. This changes your fraction to 12 over 1 multiplied to 5 over 1, which is a lot easier than doing 12 times 100 and then 20 times 1. Okay, that was the skill in exercise 3B that I wanted everyone to practice. Then now you can do top with top, bottom with bottom. Turns out that you get 12 times 5, 1 times 1, 60 over 1. But remember, 60 over 1 just means 60 divide 1. So that's why that's the same thing as writing 60. So you can see why Fraser's method was a lot faster because it conveniently 20 fits into 100 5 times. So Fraser's method using equivalent fractions, yes, that is faster, but it doesn't always work because if I changed it to 21, you then had to simplify a different way. It would have been 12 and 21 that you can simplify. Okay? Whereas if that was 21, you can't do equivalent fractions. Not easy. Yeah? So times 100 is how do you make it a percentage. So this is 60%. Make sure to put in that percent symbol. Otherwise, your answer's wrong. So if I don't see that percent symbol in a test, I'll take it off the mark as well. Okay? It has to have the correct units. Next one. What about if I had $1, if you had $1 in your pocket and Mr. Train gave you an extra $7, what is the percentage gain? Now be careful with this one. A lot of students get this one wrong. Percentage gain. Now just to make sure that you're not doing this wrong, you had $1 in your pocket. Now you have an extra 7. How much do you have overall?
8.
8. Good. Fraser?
You gain 700%.
That is actually correct. Very good. Some students will get this part wrong. So, you gained an extra $7. That's the gain. So most students understand gain. They say, oh yeah, I gained an extra $7 from Mr. Tran. But how to convert that to a percentage, not all students understand how to do that. So you gained 7. But if you want to convert to a percentage, you need a proportion. And this is what I was teaching my year 12s in foundation maths. Which one do you put it out of? Is it 7 out of 1 or a 7 out of 8? See, do you write 7 out of $1, which is what you started off with, or the $7 out of your $8 that you gained in total? Most students will do 7 out of 8. Why? Because this feels like the real thing. It feels like a fraction, right? And then they would then say, to convert it to percentage, times by 100. But this is wrong. That technique is wrong because it's not $7 out of $8. You never had $8. The $7 is what you gained. $8 is not something that you had. This is what you had. You had $1, so it's 7 out of what you actually had. So it should be 7 over 1 times by 100 to convert it to a percentage, times by 100, and conveniently, if you times by 100, you can see top with top, bottom with bottom, The answer gives you 700 over 1, which is why Fraser was correct. It's 700% increase. Okay, because you started with $1, and now you have 7 of those extra dollars. That's 7 times the amount. 7 times the amount is 700% increase. Okay, and this is called percentage change. A lot of students struggle with this bit because they forget how to go, is it 7 over 1 or 7 over 8? So once you go through the exercises, just try to remember that bit. It's what you had. It's always something that's solid, something that you actually have, not a hypothetical thing you have. It's like stocks. You know, like you might invest, but you haven't got the money yet, right? You're predicting that in the future this thing is going to grow, but you don't know that. So you only can rely with what you actually have, and that's the solid amount. That's where you start off with. Yeah, so it's always the amount you currently have, not the future amount. All right, cool. Let's skip now. I don't want to do unitary method yet because this sometimes students rely on this technique only. I want you to actually learn the proper way. Then next session I'll go back and teach you unitary method. Okay? Flip the page. And we're going to do this last example. I'm going to rub out my last year's notes for this. This is what I want you to learn from exercise 3H. Exercise 3H technically has 2 ways to do it. I want you to learn this method first. Okay, so from junior maths, from year 7 to 9, you're learning skills. Everything you're learning is just skills. After year 9, you then decide which type of maths you want to do. And some of those maths, you never actually use the skills again. So in real life out there, I don't always do half plus a third. I just use my calculator and just solve it, right? But knowing the theory, then you understand the maths that you're applying. If you don't learn the theory from year 7 to 9, we just move on. From 10 to 11 to 12, teachers can't teach you the basics anymore, and they then just have to teach you, this is how you do. So when I said that I was teaching my year 12s, they don't learn the theory anymore. They literally just learn how do you do it in real life? How do you calculate your taxes? How do you do superannuation? How do you, let's say, take a loan from bank, and then after 3 years, how much interest do you accrue? See, to do that, they don't need to learn the theory anymore, but they do need to know how to do it on a calculator. So for you guys, since you're still in junior mathematics, we try to teach you the theory. Those who get the theory well can branch off into methods and specialists because they rely a lot on theory. If your theories aren't strong, algebra would be weak. Therefore, you can do general maths and foundation maths, which is a lot more applied. It's real life mathematics. This one, it's not that it's not real life, it's just a lot of hypothetical thinking. So it depends on how strong your hypothetical thinking is, meaning theory. Okay, so if you're finding maths really difficult so far in terms of theory as I'm describing it, then know that in the future you might find general and foundation to be more useful because it's actually applied maths. That's what it is. Yeah. And for those who can work in abstract thinking, theoretical thinking, well then methods and specials relies on the fact that you understand the theory. And the best way for me to know is just looking at your fractions to start off with. How well do you understand fractions? Because you learnt it from grade 3, grade 4, you did it 5 and 6, and you did it in 7, that's 5 years already, then plus 8, and you're going to do a bit in 9, though they don't really teach you it again. So by that time, you've had more than half a decade to have mastered a skill that you're meant to have. If you didn't learn in those half decade, 5 years, you just move on. So therefore, theory-wise, you get a cap. Okay, so if you want to get into the theory component, I highly recommend that you learn your basics. So multiplication tables, factors, fractions, decimals, percentages, all of the things you learn in year 8 is the foundation. Okay? Gives you a bit of a direction. So this is the skill that I want you to learn from 3H. If you can do it this way, fantastic. If you can't, don't worry. I'll teach you other ways than using a calculator. Yeah? But here we go. Method 2, this is the key part. When you're trying to find what is 32% of 20, I want you to learn to interpret what that line actually means. Here we go. We already learned what 32% means. What is 32% truly? What does it mean? 32 out of 100. So literally write it. 32 out of 100. Now the next one, students tend to get this one wrong. And I know why they get it wrong as well. What's of mean? Times. What do you think a lot of students say? Divide. Why do you think they say divide? And I know the reasoning. It's because when you say half of 10, you tell me it's 5. But if I asked you how you did it, you would have done 10 divided by 2. So that's why when you say half of 10, you think, oh yeah, it must be divide. 10 divided by 2 is 5. But the mathematics to it is half times 10 over 1. See, top with top, bottom with bottom, you end up with 10 over 2. Then it feels like 10 divided by 2, right? But the logic was always times. Okay, so for those who didn't know, of is times. Make sure to write that in so that you remember. And then we're doing times 20. You see how this is the fraction method? Because this is going back to exercise 3b again, your foundation. To multiply fractions, you can do top with top, bottom and bottom. And again, how do you write 20 as a fraction? Yes, Pierre. 20 over 1. Right? So we can do top with top, bottom with bottom, but the numbers will be really big. Your goal is to simplify it first. What two numbers can you see, Harrison, that we can simplify?
120.
Yeah. Now you can do 32 and 100 as well, but try to find the big numbers first. The bigger the numbers are that you can find a common factor, the smaller the fractions can be. What number goes into 20 and 100? 5 is 1, but there's a bigger number. 20. So I can go 20 goes into 20, 20 goes into 100. 20 goes into 20 once, and 20 goes into 100 5 times. Okay, so now you end up with 32 over 5 times 1 over 1, which is a lot easier than what we had before. 32 times 20 is a lot bigger. Now you can do multiplying fractions, top with top, bottom with bottom. You don't have to make denominators the same. So 32 times 1, 5 times 1, that gives me 32 over 5. This is my percentage, or the amount, sorry. That's the amount that I will have, but we don't speak in those terms. In reality, we talk about whole numbers or decimals. So 32 over 5, let's convert that to a mixed fraction. How many 5s fit in 32? 6. So it's 6 times and rounded 2 over 5. So some people might understand 6 and 2 fifths, or you can actually do 5. How many 5s fit into 32? Now this is exercise 3F. See if you can do division of numbers. Let's do it. How many 5s fit into 3?
0.
0. So you carry the 3 over, becomes 32. 6, remainder 2, carry the 2 over, but don't forget the decimal. 4. So the answer is 6.4. So that, when I ask you, what is 32% of $20, you're getting $6.40 is what 32% is. So if I told you there was a reduction, so you get a discount of 32%, that you know it's $20 minus $6.40 is how much you're going to get, well, going to be paying for the amount. But the problem is the 32%. And that's what I was teaching my year 12s, how to do this on a calculator. So all they had to do was literally read this bit, and on their calculator, this is what they type. 32 divide 100 times 20. And I should get 6.4. So watch, I'll go on my calculator. This is what I was teaching them. To apply the mathematics, if they got a 32% discount, we go 32 divide 100, so that's 32%. Of means times, and that's what the dot means in the middle, that means times. $20, so 32% of 20. And that's what they were doing. They get $6.40, and now I say, all right, well, in an applied situation, if the shoe was $20, they got a discount of 32%, how much do they have to pay? So the year 12s then go, yep, $20 for the shoe, but minus the discount, they're paying $13.60. And that's what they're practicing. So less on the theory, but applying it. So then we can do that for superannuation or GST. Your taxes, you need to be able to know how to do percentages to work it out. But for you guys at a junior level, this is what we're training. Hopefully you get it this year and by next year. And if you don't, there's always applied maths that could be still useful. Cool? I'm going to stop there because that's all I want you to really learn for now. Next session, I'll teach you some shortcuts that you can do this without a calculator to some degree. Because most times when you go shopping, they usually do 25% discount. They usually do 10%, 30, sometimes 40, sometimes 60, and sometimes 70. Right? But they're all multiples of 5. So you can actually do all this in your head. It's only when you get 32, 33, that's a lot harder to do in your head, but you can do these a lot faster with what we call unitary method. I'll show you next session. But for now, I want you to train this skill that revises your 3B, and the next lesson I'll teach you the shortcut. Okay? All right, team, we'll stop there. Thank you. And this session is about making sure you've got 3F, 3E, 3C you can kind of skip-ish, but ideally you learn the theory. So if you haven't done 3B, please, that should be your foundation. Really got to get good at 3B.